Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on hypothesis testing on the mean. We will look at problems with the x normally distributed and the sigma or the population standard deviation unknown. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoints to make this set of videos. We are learning a particular technique, and when learning this technique, it will help you to think of this procedure as a series of steps. And by dividing it into steps, Mrs. Borlaug has tried to make it easier for you to remember what to do and what order to do the steps. Your teacher may use a different number of steps or a different technique, especially if you're not from Walters State. For Walters State students, this is the classic approach and should work for your teacher, but always, as always, please verify with your teacher. The steps that we will learn in this video are to set up the hypotheses, the null hypothesis, and the alternate hypothesis. We will put what we want to prove in the alternate hypothesis H1, and remember that the equals must go into the HO. Unfortunately, remember that you can never prove the equals with just a sample. Step 2 is to define the critical region, abbreviated CR, using the alpha risk. Step 3, use the data to find the test statistic, abbreviated TS, and based on the data we will make a conclusion, either to reject the null HO or to do not reject the null HO. And we do this based on the data by comparing the test statistic with the critical value. And then lastly, to write a sentence in terms of the alternate hypothesis H1. Summary: there are 5 steps in hypothesis testing. For Ms. Borlaug to make things even easier, she has set up a wonderful structure for us to use as well. And this will keep things in order and help you to have a visual key or cue to help you remember what to do next. So notice what this looks like. You will divide your paper into 2 sections, and then on the left section you divide it into 2 sections, and on the right section you divide it into 3 sections. Notice that it's divided exactly in half, but then the subsections are of slightly different sizes because each of the steps takes a little bit different amount of room. So first we do and write the 2 hypotheses, the null and the alternate. Then we have the critical value, then the test statistic, the conclusion, and then our sentence in terms of H1. The best way to explain the steps is to do an example. Example number 1. A manufacturer produces rope. The breaking strength of the rope is normally distributed. A random sample of 10 ropes is taken, and their breaking strength in pounds is measured. We have their breaking strength of those 10 samples listed: 284, 300, 304, 293, 300, 311, 274, 305, 282, and 330. Using a 0.05 level of significance, test the claim that the mean breaking strength is less than 300 pounds. Since we have data listed, the first thing that we will want to do is to find the sample size, sample mean, and sample standard deviation using our calculator, and that can be a TI-84 or a TI-83. We will put the data in list 1 and then do one variable statistics. I won't go through the details of that. I have explained that in previous videos. Once we do that, we get a sample mean of 298.3, a sample standard deviation of S equaling 16.1180, and a sample size of 10. We had 10 numbers. We will use this later, so be sure that you write that down and keep it where you can see it. So what is the first real step in the hypothesis testing? And it is to set up the hypotheses, the null and the alternate hypothesis. To begin, let's reread the claim. Using a 0.05 level of significance, test the claim that the mean breaking strength is less than 300 pounds. We will use the significance level in step 2. So let's concentrate on the next statement. First, we know it's hypothesis testing when it tells us to test the claim, and that we're talking about that the mean breaking strength is less than 300 pounds. Notice that the claim states that the mean is less than 300 pounds. This does not contain a value of equality. It is strictly less than. Since the statement of equality must be in the null hypothesis, the claim will go in the alternate. Plus, this is what we want to prove. Since we want to put what we want to prove in H1, and because it does not have the condition of equality, we know that that is correct to put it into H1, that the mean breaking strength is less than 300 pounds. But we don't want to write it in words. We want to use symbols. Notice that we're making a statement about the population mean, and the population mean is used with the symbol mu. So we will say that the mu is less than, using the symbol, 300 pounds. Next, it's time for us to fill in the blank for the null. Remember that the null and the alternate are complete opposite statements. So what is the opposite of being less than 300 pounds? If it is not less than 300 pounds, it must be greater than or equal to 300 pounds. Remember that equals must go into HO, the null. You can never prove the equals with just a sample, and remember that we're not trying to prove the null. So the null hypothesis is every other possibility, therefore the greater than or equal to 300. In some textbooks, the null would be just listed as the mean is equal to 300. Either way, the critical value is based on the mean being 300. Now, here is a hard part. Different teachers and textbooks cover this a little differently than Mrs. Borlaug. For Mrs. Borlaug, what you want to prove is how she refers and thinks about what goes into H1. And the opposite statement will always have the equality and go into the null. Other teachers and text approach this from the point of view that the claim can be anything, but that the null must be the equality statement. In both cases, the results really come out to be the same, and the conclusions actually come out to be the same. In that, the null will include an the null will include the equality less than or equal to, greater than or equal to, or equal to, and the alternate will not. It will be either less than, greater than, or not equal to. The difference is that for Mrs. Borlaug, that all of her claims will contain the strictly less than, strictly greater than, or the not equal to. And for some teachers, they'll have anything in their claim. That's very confusing. So for this video, I will stick to Mrs. Borlaug's method, and in an additional video that I plan to create, I will do a further explanation on writing hypothesis. But again, for this video, I'm sticking to Mrs. Borlaug's method. This will be a one-tailed test. Remember that confidence intervals are always two-tailed. But for hypothesis testing, we must decide whether they are one or two-tailed. And this will be a one-tailed test because we're only interested in proving that the mean is lower than the claimed value. To determine the number of tails and the direction of the tail, always look at the alternate hypothesis. The alternate hypothesis says that the mean is less than 300 pounds, so we will look at a left-hand tail test, a left-tailed test, because less than will shade to the left. And let's look at what I mean by shading to the left by moving to step 2, which is to define the critical region, CR, using the alpha risk. To define the critical region, abbreviated CR, we will use the alpha risk to create a tail in our normal curve. Remember that we stated our data should be normally distributed, so we will draw a normal curve. And since H1 tells us that we're interested in proving that the mean is less than 300 pounds, we will place and shade that to the left. Since this is a one-tailed test, we'll put all of the alpha risk in one tail. It's less than shades to the left, so that means the tail is to the left. We're using a 0.05 level of significance, so that tells us that our alpha is the 0.05. We need the value, the critical value, that is associated with this tail. And we will use the t-table to find that critical value. Since the area in that one tail is 0.05, we will look at the column that says 0.05, but we know that the row has to do with our degrees of freedom. There were 10 pieces of data, so 10 minus 1 gives us 9 for our degrees of freedom, and 9 with 0.05 in the area in one tail gives us 1.83. Notice our critical value is negative. We have to know that this would be a positive value if it were on the right, but it is a negative value since this is to the left. So you have to be able to do that yourself. And at this point, I am out of time and will pick up just where I left off in part 2 of this series.